Hello everybody and welcome to FyneConf 2021. It's such a great honour to be back in front of you all. I can't believe that it's been over a year since our last event. How much stuff we have covered in that time. I would like to explore all of those things. But before we get started, I wanted to also thank everybody in recognition for the tough year that it's been. Thank you to everybody who's contributed to the project, whether it's through code, features, bug reports, or being part of the community and just helping it to be a fantastic place to contribute code and grow this excellent project. If you have questions during this afternoon, please do ask them. We have the YouTube live channel. We have Twitter at Fyne_IO, or you can ask in the Fyne channels on the Gophers Slack or Discord servers. We'll try to answer them on the platform where you ask, but also if there's a chance in between presentations, we'll answer them there as well. Sorry. Before we get going, I wanted to just start with a reminder of why it is that we're all here. The vision of the Fyne project. Why does it exist and where are we heading? Well, I think that it's a fine future out there, and let me explain to you why. Applications, especially modern graphical applications that we're so used to, they shouldn't have to be written per platform. They're not OS specific. Just like how the web took off with a build once and works everywhere kind of approach, the same should be possible of all other software. Apps should just work everywhere and only need to be written once. We don't think that applications should need installer software or libraries running on the application's host server or desktop either. They should be able to run just after download, as we've seen some platforms already perfect. There's an opportunity to work with modern languages and programming techniques to throw out the legacy problems that we've experienced in the past. If you've ever had to build a graphical app and struggled with main threads, memory management, all of those problems, they should be a thing of the past. We have the technology and the functionality to be able to do better. And Go as a language is a fantastic fit here, and I'm very glad that we chose it to underpin the Fyne project. All of those things are really important to this project, but also we would love to be part of lowering the barrier of entry to building graphical applications. It should be really straightforward to get up and running and build what's in your mind. In fact, we've had great success so far. A lot of the people coming to the Fyne project are telling us that this is the first time they've built an application and they found it really quite straightforward and maybe even were surprised by that. Don't tell the no-code movement that we're solving this one. We think that applications should look great just out of the box as well. They shouldn't need necessarily a design process to be able to pull something together that you're proud of. And we think that the standard library of themes should be able to provide that functionality straight out of the box. We also want to promote good engineering principles, whether it's test-driven development, separation of concerns, or things that the Go tools provide for most applications like lint, documentation and so forth. We can make it easy for everybody to get involved in software development. And naturally, Fyne and all of its projects are licensed under a highly permissive open source license, forever free and supported by a fantastic open source community. In fact, I think it could be summed up well by a quote on our website, that Fyne aims to be the best toolkit for easily developing beautiful native graphical applications for desktop, mobile and beyond. And hopefully today you'll see how we're managing to step towards those ambitions and hear a lot more from the people in the community about how they are helping to move it forward. But let me just step in now to what's new in Fyne. And this is, I think, a bumper edition. It's the first time that we've had 3 major releases from one FyneConf to another. There's a lot that's happened since 1.3. 1.4, this was last year, included collection widgets, a theme update, and input validation. We then followed up with a very large 2.0 release where we included data binding, storage repositories, animation, and much, much more. Version 2.1, which I'm very excited to say is launching today, adds a lifecycle API, rich text functionality, doc tabs containers, a documents API, and many widgets as well. We'll step into all of these in a little bit more detail. Also, we launched a book at the beginning of this year at the same time as the 2.0 release. Thank you for Jacob's help and the Pact publishing team who were really instrumental in making this happen, and thanks to everybody involved in working through testing, reading, or suggesting ideas for it. As well as all of those, we have had a lot of activity in the community. On GitHub we passed 14,000 stars just recently. We have more than 700 members in our Slack channel, and we've passed 80 contributors to the project as well. All really big numbers and very exciting. You might notice that the version numbers on this slide don't represent the version numbers of a release, such as v2.0.3. And that's because we started grouping by API version. So 1.4 represents what was added in the 1.4 API version, and you will find that there's various releases after that. New functionality would then come in the next release. This time it was 2.0. And when you see the first number change, it is a chance for us to make major updates that might not match our backwards compatibility guarantee. But let's look more at those releases. 1.4.0 was the first release that introduced the new collection widgets. The list, tree, and table help to deliver a more performant user interface when using large amounts of data, and I'll talk more about that in a moment. We added other new widgets, the card, which replaced the older looking group widget, file item, used in a lot of places like file browsing widgets and so forth, and the separator, which you can see is being heavily used in the collection widgets as well. We added input validation so that you can give users feedback as they're typing. Not too intrusive, we hope. It hints at just the right times that they may wish to go back and check something. We added a color picker dialog to the collection of dialogues that are provided. And we updated the default theme. And this took the opportunity to allow user configuration of the primary color. The default is still blue. It's changed a little bit, but people can now pick one that better matches their mood or preferred color. And we also added a release subcommand to the Fyne executable that supports releasing apps to stores and marketplaces, which means that your Fyne app that previously could be bundled for your local computer could be prepared for releasing out to marketplaces with the same tools, not having to go to platform-specific build commands. Anyhow, let's look at those collection widgets. So you can see here is the table is pictured. Like I said, these collection widgets are for handling large data. We provided list, tree, and table, different ways of working with data depending on the structure of the data that you've loaded. It uses heavy caching of the graphical elements, so we're only ever drawing as much as is really required for visibility on screen. And because of that, we're able to lazy load the data. So you could have thousands or hundreds of thousands of items in your dataset and find no slowdown in scrolling or manipulating the data that's being presented. That was a big step forward. Anyhow, onto the version 2 release, the 2.0.0, which was the first release there. We added data binding, which I'll explain a little bit more in a moment. Storage repositories were a big part of being able to provide data from various different places into your application. There'll be a presentation about that later today by Charles. We added support for animations as well, and I'll speak just in a moment about that. We added even more flexibility of theming. providing the ability to customize icons, but also allowing the theme to be expanded over time. It was quite rigid before, and allowing more types of customizations as well. And we added validation and hints of what was going on into the form widget. This was a really great contribution by one of our new community members who was able to integrate it really well. So the form flows like it was a set of input instead of a lot of separate entities, made a much more natural experience. And because 2 was our first breaking release, we did take the opportunity to tidy up some things that perhaps weren't designed best at the very first release that many years ago. We updated to a floating point precision so that things are much more precisely positioned on screen, which really matters with high resolution displays. And we tidied up various deprecated APIs. Lots of information about what was changed is available in the upgrade notes for 2.0, which you can check on our website. So data binding, this sounds a little bit mysterious. Well, it was an opportunity to provide a better integration between the data types that you might have stored in your application and the widgets that might consume it. We started out with bool, int, float, rune, and string, which all map quite clearly to standard primitive types under the hood. And these provide two-way bindings so that if something is changed at the source, it will propagate out to a widget. And if it's connected to a widget that can edit, like entry, the data change will be pushed back as well. And this all happens completely transparently. We added some more complicated structures, such as list, untyped map, and struct. Now, the list provides a list of each of the primitive types, so a string list or int list. Untyped map is a map of string to any type, the interface type in fact, which could be useful in all sorts of contexts. The most intriguing is struct, where you can bind to an existing structure, and that's going to use an untyped map under the hood, but the API to work with it is oriented for the struct itself. And extra awesome was that we managed to connect the data binding to preferences. So if you want your widget to be responding to data that's originated, stored, or managed by part of the application preferences, you can use bind preference string, for example, and that will load when your application starts to be the content that was saved, and when you edit it, it persists it so that it will be loaded next time. A really handy shortcut. But let's just look at some code there. So how is that going to be used in a widget? Well, first, we create a new string binding. In this case, we're creating a new string in memory because we're going to let the widget manage, the data be managed. We're not using an external source where we would use binding.bindString. And then when we create a new entry widget, we just use new entry with data and pass the binding in. And that's all there is. That input is now an entry just like any other, but the data is going to be stored and loaded automatically inside your application. Now, what if the data type that you have doesn't match exactly with the type that you want to display? So we added conversions as well. So in this case, you might find that your source data is a float, but you want to use an entry widget like before. So you would use the conversion function float to string. In this case, it's illustrating with format. And so in this case, the float that you have is going to be rendered to screen with the value prefix. And that is going to be sent to this label widget in the example here. So you can use a number-based data source and present it to screen, even without a standard format if you're quite happy to do the normal conversion. So hopefully those data bindings have helped people to advance what their applications are capable of, but also we added animations. You can in fact animate everything that you want. It's just a wrapper around a time slice that's optimized for drawing. We provided size, position, and color animations built into the main library. So what does that look like? Well, here we show how you could construct a position animation. This animation is going to move your object from 010 to 9010. So that is sliding along the x-axis. We're giving it a standard duration. There are a number of different durations. Standard is what you would use if you didn't have a particular reason to go faster or slower. It means that it fits with other transitions that the standard library has added. And inside the callback function, we're told the position to move to, and this will be called for every intermediate position as the time progresses. And then we call anim.start. You can stop your animation, of course, and there's parameters to animation, so you can loop it, you can automatically reverse it, and you can set curves as well. Let's just have a look at that. There is an animation demo inside the Fyne demo app, and here's what it looks like. We can animate the color and the size and the position all at the same time. And in the bottom half here, we show the different curves that are available inside the animation framework. 2.0 was a very big release, and it was the first to change certain items in the API that we thought we'd learned a lot during the development and wanted to remove or migrate. So it was the first breaking release. But it was really heartening to hear from people, to things like this Redditor who spoke up in Golang to say they wanted to say that with 2.0 the Fyne API was even easier to use, especially with data binding. And I think that says a lot, especially when we've been trying to be easy to use all the time, so to be better at that is pretty excellent. Now, having said that 2.0 was big, today we're launching 2.0.1. And this release, although it seems like it's got a smaller number jump, was just as big as 2.0. Both of them had over 1,000 commits contributing to the code. We have added a lifecycle API. This means that your application code can respond to the application start and stop, a window foreground and background, certain elements that haven't really been accessible before. And we're going to add to that over time. So if you have certain lifecycle events that you want to listen for, like a large change in time if the application's been suspended, or location change, that might be possible as well. We have added the doc tabs widget, and that means that you can now handle multiple files in your UI. It's a little bit more oriented for file management than the app tabs, which is more about areas of your application. Rich text was added. I'll speak a little bit more about that. And check group as well, which enables you to have slightly different input requirements in your forms. The rich text which you see there can be manipulated directly through a text segment API, but much easier is with the markdown parser that we've also added. So if you want to include rich text in your application, you can load markdown either from a resource inside your application or from a remote server. Other data sources are available, as we'll hear later in the day. And that's going to do the conversion for you. And I'll have to show you a bit more about that. And we added a document storage API, which helps you to quickly manage documents inside your application. And we'll cover that in a little more detail as well. Lastly, we added a build metadata file. Now, this was not something that I wanted to do from the very beginning because it felt like it was making things a little bit less transparent. But really what it's doing is it's just taking standard options that you can present on the command line build and putting them in a file so you don't have to specify them many times. And we'll take a quick look at that as well. So the document storage API, like I said, it's a way to help manage where you want to just quickly save application documents that the user is going to come back to. Imagine a text editor or somebody who's just taking quick notes. They don't necessarily want to know or care where it's stored in their hard drive. They just want to have their data available. These are going to appear inside the file dialog sidebar as well. If your application is using this API, then it will appear. And if you don't specify a start location for the file picker, it will default here instead. And these are the standard function calls provided. They're available under app.storage, and each of these subfunctions pretty much do what they say. you can create a new document with a name, open an existing document, or save out to a document that previously existed. And you can remove them as well. And then there's a convenience list function. So if you just want to provide your users a chance to see what they've created and maybe pick one of them without going through File Picker, you can do it that way. Rich text, yes. This one, I just want to step through a little bit of code. I think it shows quite well what it's capable of. So we'll start our main package and we'll do the standard imports, app, container, and widget. More details about them in the next presentation about the architecture. We'll open our main function and create a new application. Again, all standard if you've ever made a Fyne app. And we'll create our new window titled Markdown Editor. We'll create a new entry, this time a multi-line entry, because we want to be able to edit larger amounts of text. And we'll create a rich text widget. This is part of the 2.1 API. And there's a helper there saying from Markdown. In this case, we're actually not passing any Markdown, but you could do there a default content. That would be really great if you were wanting to use it for displaying in your application a rich label or something. And then our editor, we set onChanged, which is a function callback when the text content changes, to be the parse markdown function of our rich text widget. Now the function signature is to take a string parameter, so the onChanged tells you the latest version of the string, and parse markdown takes one string, which is the source markdown that it's going to render. And actually that's our entire editor. We set the content of the window to be a horizontal split with the editor on the left and the rich text on the right, and we show this window and run it. Not many lines of code there, but what you have is a complete markdown text editor where you're editing text on the left and it's live updating on the right, as you can see in the screenshot here. I think that shows the power available in some of these APIs. But before we wrap up the 2.1 summary, I just want to touch on the metadata as well. We've chosen to use TOML. It's the most human readable metadata format that we could find. Like I said before, it's about making your build commands shorter, but it is completely optional. It also enables you to keep the metadata that would be passed in build commands inside the repository. So if you're working in a team environment, or if you want to make it easier for people to get started with your code, then there's fewer parameters for them to remember. Also, because build number is part of the metadata, we can keep track of the build number, and every time you package your Fyne application, it will auto increment. And so let's just have a quick look at what that file looks like. This is a full example. More fields will be added later, but this is the start. You could specify your website, which is just metadata about the application, and then details specific to the binary. The icon that will be used, the name that should be put on the icon, and the ID, which is really important if you're using preference or storage, or even if you're distributing a standard app but on the mobile platforms. They require an ID, and I think Windows does in the latest versions as well. And we use a version number that is up to 3 digits long. If you're familiar with Semver, this shouldn't be much of a surprise. But if you're a Windows developer, you might be thinking, but I have 4 digits. We have a build number there at the end as well. And for most platforms, the version number stays the same and the build number increments. But when you package for Windows, it's going to append those two so that that would result in 1.0.0.5 for this build on Windows, and you would get a version number as expected. Along with each of these updates along the way is an updated version of Fyne Demo, which is really the best way that we have to showcase the latest functionality being added to the toolkit. If you don't already, you can install this or even upgrade your installation using go-get-u and the package fyne.io/fyne/v2/cmd/fyne_demo. And that's going to install it into your standard path. And you can run it using the command find_demo. If that doesn't work, check that your Go path is set up, or your standard path. Maybe check out the Go documentation if it's not quite working. If you do that, you'll see this, the very latest version of the Fyne demo application. You can see here that it just illustrates the new check group item. But if we just pop out, I can see what the latest version is looking like and demo it. And I think that you should be able to see here the Fyne demo application. Standard welcome page hasn't changed a huge amount, and these links will take you to the standard locations. We add new canvas elements here, and each time there's new icons, we add them to this list so you can preview them. The animations I demonstrated are on this tab here. And the file dialog that I mentioned is available through the dialogues area. I just had to tap a few approvals on my Mac there, sorry. And this is the app files that I mentioned, which appears when your application uses the storage API and doesn't specify a different location. Data binding, you can see various examples of how that's working here. And for all of the latest widgets, you can find them in one of these groupings here, such as the input, or indeed text, where we illustrate the marked up text and the latest editor capabilities. Well, thank you very much indeed for joining me for this first segment. We're going to take a short break and then come back with a brief discussion about the architecture and the design of the Fyne platform. I'll see you then in just a couple of minutes. Hi, and welcome back to FyneConf 2021. We do have 5 other great speakers, which I can't wait to welcome to the event today. But before I do, I'm going to do one additional segment about architecture and design. Hopefully this works as a refresher for people who know the project, or a chance to understand it more, and an introduction to anybody who's brand new to what we're doing here. Now, our design is split into the user interface and the API, but I thought I would start with the UI design. As you'll have seen earlier, and are probably quite familiar, this is loosely based on the material design language. It's a really great place to get started. They've worked so hard on a fantastic look, and their icons are really excellent. We embed them so that they're available for all of the Fyne applications. But we found its background can be a little prescriptive at times, having come from a web setup and then moving into Android. It didn't necessarily adapt well to the desktop. So we've made some tweaks here and there. You'll notice padding is slightly different font size as well. It's an opportunity to work consistently across these devices and yet not look particularly out of place. In fact, if you're on Android or on Windows 10, it might even look quite natural. We have used vector graphics throughout. If that doesn't mean much to you, don't worry. It just means that we're not placing pixels in the way that these widgets are designed. It's going to scale really, really well, whether you've got a low resolution screen that's far away or a very high resolution screen right up close. The applications are going to adapt and look crisp. It delivers a light and dark version of the default theme, and we encourage people who are writing their own widgets or their own themes that they do the same, because applications are going to adapt appropriately, and it's best for the users if it matches what their expectations are. We provide a lot of standard widgets, and these conform to certain layout and theme definitions that are documented through both material design and our own documentation as well. It gives a really consistent user experience. It may not be exactly how other applications look on their system, but it will feel familiar and really easy to understand. And simplicity is really key. We know how important it is that it's easy to build an application, but it should be equally easy to use the applications that have been built as well. At the core of this, of course, is to be a platform agnostic toolkit. And what does that mean? Well, in case I didn't say it earlier, this is writing your application once and expecting it to run everywhere. Here, your first Hello Fyne application launches in the font size you would expect in the theme that matches your desktop. When you run it on a different type of device, it's going to adjust the scale. Here, a side-by-side comparison doesn't seem identical, but when you're holding your phone, that font size is equivalent, so it's making this adaptation for you. For each platform that the application can run on, the drivers, which we'll look into in a moment, are going to handle the different behaviors for multiple windows, how notifications are sent, and how the application process for installing is going to work as well. We do our best to make sure that the default theme and font size and preferred color are going to match the user preference. But if you wish, as an end user, you can override these settings. You can specify a bigger or smaller scale, like you can see there, or you can specify the dark variant of the theme if you think it matches the application better, or if your operating system default isn't being picked up for some reason. And all of these things can be configured by the toolkit settings application, which is also available in the Fyne repository. And if you run Fyne settings, it looks like this. You could see that the normal font size is default and the blue color is, and the theme is going to pick system default. But if you prefer, you can override any of these for your particular preference or setup. And the way that this is built means that although the custom themes are there, although the standard themes are built in, applications can deliver custom themes. And these are just going to work with the standard widgets and also with any custom widgets that are correctly using the theme API. So here you can see a BBC Micro emulator that I built on top of somebody's Go library for parsing basic programs. That was a lot of fun. And what you see is really just a label with multiple lines of text and a background, but it's all updated to the theme that's built into the application. And if you want to explore what theme capabilities could be, or if your application is looking for a brand identity or a different style, you could try out something like this theme generator that's been built by Kiyosuke Fujimoto at the URL found below. And that's a great opportunity to see how things vary in the standard widgets. And it's a live updating interface based on the current selections. And then you can save your current state into a Go file that it can be then packaged into your application. So that's the user interface design, but the API design is just as important. And so we've thought long and hard about how this should be done. Firstly, we have implemented basically everything here from scratch with the help of some really great libraries like GLFW for one. But we've taken this opportunity to start from scratch. We've removed all of the legacy constraints that graphical app developers might be familiar with, working with a main thread, communicating across them, managing the memory of your widgets and the life cycle of the graphical elements. That's all gone, and so we're able to start with something much simpler. The code is focused on behavior, not on render details. And this is a big difference and quite a step for people who are more familiar with developing web applications, for example. We're not really an API that says I'd like to move it a bit further to the right or a slightly different shade of foreground color. It's more about what's the user going to do. I want an entry widget and I'd like to set this text to be selected, that kind of thing. We're also very careful about the naming of everything in the API. It has to be really obvious. A consistent API that's minimal is going to be so easy to learn for a new developer, and we don't want it to get much more complicated, because although the developers of the project might be learning and building up on top of all of this, somebody coming to the project new doesn't have any of this built-in knowledge, especially because we've changed some things about how graphical APIs might be delivered. So we're trying to get a path of least surprise for developers. It should be clear when writing code, obviously what things are going to do. And with a little prod from a good IDE, it should be possible for all of this to be quite clearly written with a little autocomplete here and there. Also, separation of concerns is a big element of maintainable software, and the Fyne toolkit is certainly growing, and I hope a lot of applications that build with it will too. By keeping things modular, we can enhance the reusability and make things easier to test as well. If your application is broken into components, everything is a little bit easier. If you'd like to learn more about this design process, there's a blog post on Changelog's website based on a Go Time episode, number 116, where we talked about Fyne in its early stages and how we approached the design of the APIs. And we've really tried to stick to that. Now we should look at how this looks on screen. I've called this canvas architecture. It's about how it's created and presented to the user. The approach that we've taken is a stateful API. Now, this doesn't have to mean much, but if you've heard of immediate mode, it's basically the opposite. We store state for widgets, and we only refresh if that state has changed or if the developer requests it. At the top of every window is a canvas. That's the base of our abstraction. The window itself is part of a driver, and we don't need to worry about it. We control what's inside. Every window will contain many canvas objects, which are the primitives that can be drawn, and it probably has a container, because that manages multiple different canvas objects and helps to lay them out. we'll hear more about canvas and layout. We'll hear more about containers and layouts from Jacob later on. A widget, which you can sort of see at the top right of this illustration, is where we add interaction. Basic canvas objects are just drawing. But at a widget level, we can start interacting to tap, drag, and all sorts of other events as well. Users can also extend widgets. So if you would like to add some functionality to an existing widget, then extending it is probably the best way to do it. You can even intercept certain events and modify it. We find this to be really helpful. If somebody wants an entry to contain only specific letters or numbers, then it's possible to intercept the typed rune and block certain calls from passing through if they don't match the expectation. And then lastly of all, you could create custom widgets. They don't have to be based on any standard widget, and also they don't have to conform to the theme. If you have specific reasons to draw something completely different, you can. But a custom widget is going to be just as well contained as any standard widget, and it can be shared around. All of these widgets are basically just a container, but it contains a minimum size and a layout as well, all wrapped in a widget renderer. More information about that is available on the website as well, if you would like to get into building custom widgets. It's not as difficult as it might sound, and in 2.1 we added a new simple renderer, which means that you can actually pass it a canvas object or a container that will be used to render your widget, and then you can just control updating its state in a refresh call. Pretty straightforward. But how do these things get drawn to screen? So we have a graphics abstraction in the architecture as well. The drawing of everything is handled by drivers that we've created. And although you might think it would be better for widgets to describe how they're drawn, or in fact for your canvas object, your line, to say here's how you draw a line, that means that we can't optimize it. And so instead they pass information about what they should be, how they should be looking, the properties that they have, into the driver, and it can do the rendering optimally in whatever way meets the platform's requirements. So there the primitive draw objects pass the item information into the abstraction. A rendered item can then be cached internally until it's asked to refresh. So if you've got one item on screen of thousands of items, there's only one thing that really needs to change there, and the graphics card's just going to keep reference to the previous state for all of the other objects. Like I mentioned earlier, a widget creates a widget renderer, and that's going to manage a list of other primitive objects if it's drawing to screen. It's also here where you might want to be careful to use the theme API if you're applying certain colors. Or, in fact, you could avoid needing to manage primitive objects in their state by reusing other widgets, because one widget could use many other widgets inside its renderer. So you could choose to use a label instead of a canvas text if you would like to inherit the default theme in all its glory. If you wish to save what has been rendered to screen, you can use canvas.capture. That might not seem hugely useful for many applications, but if you're building an image editor, it might be really helpful. But also, if you're unit testing, then you can save what's going on to a file and compare it to a golden image if you want to make sure that your rendering is correct. And all of this might sound complicated, but at the bottom line, you don't need to worry about any of it. It's an abstraction for a reason. It's all hidden away. When you call app.new, it is detecting the details of your runtime environment, and it's going to update according to the graphics technologies available, the devices detected, and so forth. I mentioned drivers a couple of times. Let me just go into the details then about which drivers we have implemented. And if you're not interested in how Fyne works internally, you can probably skip this slide. So we have the glfw driver, which is built on top of a C library, but it's all bundled in, so it's not a dependency for your users. This handles the desktop applications. It will be used on Windows, macOS, Linux, and BSD. That's going to handle input, output, and creating windows on screen, and various other things like showing notifications. There's a mobile driver. That probably has a more obvious name, and this is going to be used for phone and tablet devices such as iOS and Android, and others still to come. But more surprisingly perhaps is that there's a test driver as well. This is an in-memory driver that's going to be useful for your unit testing. This means that we can run our full applications in test mode without needing to show them to screen, without needing to take hold of the keyboard and mouse to generate taps and clicks and check that your application is doing the right thing. So that itself is also really powerful. And backing these drivers, we have some common code that are called painters, and this is what actually draws your canvas into a window. The standard one used in most drivers is GL. This is using the OpenGL hardware acceleration to render, and on embedded devices and others like Apple's M1, this is going to pick up OpenGL ES instead, which is the embedded systems version. Essentially it's the same technology but with a slightly different language for describing how it works behind the scenes. And then we have a software painter. This is really mainly used for the test driver. It has a couple of helpful pieces of functionality though. So if you wish to render a single widget without loading an application to see how it runs, you can use the software driver directly and render that widget into an image file. So that's a lot about the detailed stuff. Let's look again for something a little bit more developer level. The main packages that are part of the Fyne project. So these are all under fyne.io/fyne/v2 namespace. The one that I've mentioned a few times already, the main entry point, is app. This is where you call app.new, and it's going to do all of the auto detection and setup of your application when it's run on the host computer. I mentioned Canvas in passing. This is the package that defines the draw elements that are supported by each of our drivers. So line, text, gradient, image. There's plenty of others in there and you can see what's available. These are the only types of graphical elements that can be drawn by the drivers. You can't pass in your own because the driver just won't recognize it. And this may seem a little bit of a drawback, but it means that we can optimize, like I said, for the graphics pipeline on the device. If you want to draw something very specific, then you can use the raster canvas type, which does allow you to pass pixel data through. We have the container package and also a layout package that governs container layout. This is for grouping elements visually, logically, on moving them around on screen, and I'll let Jacob talk about that later. We have data binding, which I mentioned before, and data validation. These are places that are going to really help with the data flow in your application and to set up more complicated two-way connections that may be based on certain validation criteria. I mentioned before a file dialog and a color picker. All of our dialogs are in the dialog package. You can find things for presenting standard user information. They've got errors, confirmations, and for gathering input like a form dialog or a file dialog. The storage package we'll hear a lot more about later in Charles' presentation. That's our file and data abstraction when you're looking for information from outside sources. The test package I've also mentioned, as well as rendering an application in memory for unit testing. There's a lot of helpful tools in there that you can use. Theme provides the standard theme implementation, and you can use that to learn about the theme that's loaded. And widget is our standard pack of widgets. If that's not enough, then you can also check out the FyneX package, which is a community repository of additional widgets. Before we finish up this segment, let me just show a little bit of code for people who are really excited but haven't started their project yet. Since Go 1.16 we need modules, so we start by creating a project folder. We go into the folder, we initialize our module, we'll call it project, and we use go get to say that it will be using the Fyne package. This is our hello world code. It's pretty straightforward. We just import the app and widget packages, and much like the markdown illustration in the previous presentation, we just create a new application and a new window inside that application, and in this case we set the content to be a new label widget that just says hello Fyne, and we say show and run, a helpful shortcut for show the window and run my application. To execute this code, we edit the file, perhaps called ui.go with Vim or another editor, and we just say go run like any other application. And you might not be surprised to see hello Fyne appear on your screen. But also, we might want to write some tests. I mentioned before, test-driven development is a big part of how we're trying to make code more approachable and more reliable, even maintainable going forward. So here we have some other code. There's a few more imports here. We're importing the standard testing library and also Testify, which I find useful for writing unit tests. And we've imported the Fyne test package. Here, this is going to run a test in the normal way. We create a new entry and we use the test package to simulate typing hello, and then we assert that the contents of that entry is hello. Not much of a surprise there. But then we double tap on the entry, again using a helper in the test package. We then verify that the selected text is hello, which it is, and also that the cursor column has moved to column 5. We run this test, much like any other test. We say, go test. And this is going to be using the standard tools. There's nothing even to see when this works. When this runs. It's just going to run the test and exit. Nothing on screen, just a confirmation to your console, which means it's going to work well in your continuous integration environments and so forth. So that's an app built and run. How do we get it to people? So there's a helpful Fyne command for packaging. You might recognize the URL. It's alongside Fyne demo in our repo. We recommend on a regular basis using go-get-u to update the Fyne package. Each major release of Fyne, you might find there's functionality in there that you need to get the latest app bundles working for your app. And then we can just say Fyne package for our project. That's going to take the binary and build the metadata around it so it looks like a native application. That's by default going to work for your current operating system. If I wanted to build a Linux app and I was on a Mac, I could specify the operating system as Linux and it would build the appropriate bundle there. That will require some toolchain installation. You may have already and you might not. If that's a little bit complicated, you can use FyneConf, which is a great project that means that you don't need to manage the developer tools. It uses Docker images to provide those tools for you. We can also install Fyne applications. If you use Fyne install, it's going to install the application with all of its metadata into your operating system in a way that you would expect for a native application. Here you can see we've installed Fyne settings and it becomes available in our standard app search. You could also install it onto your Android device using OS Android. And just for completeness, you could do the same for iOS. Here you can see one of my home screen folders with a selection of Fyne applications that I have installed. I hope that's been really helpful to understand the architecture and the design of the Fyne system. We're going to take another short break, at which I'm going to jump onto some of the chat rooms and answer questions that have been coming up. We'll be back in just over 5 minutes, maybe 4. And we will welcome Jacob to the stage and he's going to tell us more about containers and layouts. Thank you very much everybody for your attention. I hope that you continue to enjoy the day and I'll see you later on.
Just one moment here. See that everything is working correctly. Oh, there we go. Hello everyone. My name is Jakob Alsen and I'm here today to talk about the layouts package and give you a guide on the standard layouts and their common usage. So let's first start with a few words about myself. So I'm an open source philanthropist, privacy advocate and an amateur photographer in my spare time. I'm currently studying my first year of computer science and I'm also helping out in the Fyne team, doing some things here and there. If you have any questions, feel free to reach out to me on the Gopher Slack at Jackals, and you can find my GitHub on github.com/jackals. But let's get into the real things here now, or the interesting things. So let's first talk about the layout package and more specifically how the layouts are defined. So if you look at the interface to the right in the top image, you'll see that the layout interface has two methods. The first one is the layout method, which takes a slice of canvas objects and a size as parameters. And this is what you use to position the resize and move widgets in the size that it is given into this layout. So if this layout has, say, 1000 by 1000 units to work in, you'll know that size inside the layout function where you try to resize your widgets or resize your widgets. And here it's worth noting that the layouting of widgets and canvas objects works from the window down. So if you have the whole window, the first container is going to get that part of the screen to function and then to render in, and then any layouts further down will just be able to render inside that part of the screen. But this means that you're not doing the kind of fixed size widget that you usually do. Everything is trying to work together in a way that works across different screen sizes and mobile and so on. But before diving into the actual layouts, I need to mention how we use these layouts. And this is where the container package comes in. So a container is a way to group together canvas objects and optionally use it with or without a layout. So in most cases you'll want to use a layout, and then you use the container.new function and then pass a layout as the first parameter, and then any following parameters will take canvas objects. And there are also shorthands for the layout package, so you can create a container with the specific layout. You don't necessarily need to create a new container and then pass the layout. And so if you're using a VBox layout, you can do the container.new VBox instead of the above there. They'll do exactly the same thing, it's just a bit less to write. And if you don't want to have a layout that handles the size and position of objects, and you want to do it manually, you can do a container.new without layout. So let's jump into the first layout. And in our case, this is the horizontal box, or H box for short. And it works in the sense that you add objects to the right of each other. So the first object is going to be the one that you see here, and then the second will be here, and the third will be here. And all the objects here are rendered at their minimum size, or the minimum width of their minimum size. And this is important because, as you see in the image here, the first item has this min size, So it's going to take up this portion, this part has this size, and this part has this size. But it doesn't resize to take make the rest of the window. It doesn't take up the rest of the window. This is a common mistake when someone passes, for example, an image which maybe doesn't have a big min size. Then this image is going to be very small and it's not going to be displayed. So you have to make sure that you're using the correct layout. But there are other layouts for that. We'll talk more about that later. So on to the sibling of the horizontal box, the vertical box. And it works basically the same, but instead of adding from left to right, we're adding from top to bottom. So the first item is going to be, for example, this username entry, and then the second, the password, and so on. And again, objects are rendered at their minimum height. So this means that, again, if you pass, for example, a list, the list is going to have the minimum size of a little bit more than a first object. So you're not going to get a big list. Be aware of that. And there are, of course, use cases where that makes a lot of sense. But now onto the grid. And here we see a more specialized layout, I'd say, because it allows us to do some clever things that we'll showcase in the future. But in large, the grid positions objects in a grid pattern with a set amount of rows or column. If you, for example, use the layout constructor here with the new grid layout with columns, and you set that to 2 columns, 1, 2, it's always going to have 2 columns as long as you pass enough objects, enough canvas objects to populate more than 1 column or so. And all these elements will get scaled so that all objects are the same size while keeping the amount of rows and columns the same. This basically means that this object is going to be the same size as this object, and when you're resizing, it's not going to add more rows and not more columns. And if this is something that you would have wanted, then you can move on to the grid wrap. And with the grid wrap, it's basically a grid, but instead of saying I want this many columns or I want this many rows, you set a fixed size for the objects, and any items that don't fit on the current row will drop down and populate the next row. And you might have seen this before in, for example, file managers, where you have a lot of icons in an icon view, and when you resize the window, they pop up to the row below, or above, I mean, sorry. So what happens in this example when we resize the window so that the third object can fit on the first line? It's going to move up into that spot. Fancy. Now I want to just take a sidestep from our layouts and talk about the first thing that isn't a layout. And this is the spacer. It's not used as a layout, but it's used inside other layouts to help control and position the size and position of other objects, mostly position. So we'll most likely see it used in grids or VBox containers, but you can of course use it in any container that you want. And in the example here, there is a spacer here, which spaces out the first part of a grid. So 1 row, second row, the third row. And then in this second row, there's a spacer, something here, a spacer, columns, I mean. And then in the last row here, there's a spacer. So this is very useful, but we're going to talk more about that in a code example in the end of the presentation. Now, let's talk about the center layout. And it's just as you might have expected. It puts things in the center of the available space for the container. And these objects are again rendered at their minimum size, so you have to make sure that you don't have a tiny min size that is not going to display anything at all on the screen. Now, maybe the most used layout in oh, never mind. It's one of my favorite layouts either way, and it's what serves the base for the form widget. And the special thing with the form layout is that it's basically what you find inside the form widget, but just you can put anything you want in the positions of the layout. So the objects in the left column are going to be compressed to their minimum size, or their width, and it's going to have the entire column is going to have the width of the largest item in that column. And you'll most likely see it used with, for example, labels in the left side and entries in the right column, where the right columns is expanded to take up all of the available space to the right. And of course the form widget also has some features, like Andrew talked about, that are not in the form layout. Then we have the border layout, which allows objects to be rendered at the borders. So top, bottom, left and right. And then there's also a section in the middle where you can position items. And the thing here to note is that all the objects in the borders, or at the borders maybe, are rendered at their minimum size, while the remaining item inside the middle, or items, will take up all of the available space. So if you, for example, you don't need to pass all of the borders here. You can pass a nil to any one of these, and for example get the example here where you have an item in the top and one on the left. Then the central item is going to take up all of the available space that is left. Also a little gotcha here that we need to make note of is that with the border layout you have to pass a reference to the canvas object twice. So if you want an entry in the top part here, you'll have to pass the entry into the layout here, and then you also need to pass the entry into the container. Because when the layout then looks through the slice of canvas objects, it needs to see that, oh, this is the entry that should be at the top. Well, then I position it at the top. This is something that you don't have to worry about if you use the container.new border, but it's worth having in mind if you use the layout package directly. Now, let's talk about maybe one of the most boring layouts, I guess, but it's also very useful. This is the max layout. It just positions and sizes objects to fill the entire available space. And this is of course the default for a window unless another layout is used. If you just pass an entry to window.setContent, it's going to take up all of the available space. And a little useful tip with the max layout is that if you pass it more than one object, and for example one of these objects are transparent, you can show them above each other, or have transparent parts, I should say. You can show them above each other, as in this example, with a black rectangle with a green circle above. And again, with what I said before, with how the space is allocated from top down, you can't put a max layout inside a container several positions down, because it's not going to like take up all of the window when this max layout is inside a container that only has a set amount of that window available to draw in. Now, last but not least, when we talk about our layouts, we have the padded layout. And this is a relatively new addition. It basically works as a max layout, but instead of drawing it exactly at the maximum size, it adds a small bit of padding around the edges. And this padding size is controlled by the theme. So it can be useful if you, for example, want to avoid having objects be right at the edge of each other. So with these 9 layouts and a spacer, you might be thinking, well, these are relatively simple layouts. How can we make something advanced and with a very useful interface? And this is where combining layouts comes in. So a container is also a canvas object. So you can pass another container into a container to basically have them work together to build up an entire user interface. So I'm going to do a short example here on how we can combine layouts to make a login screen that looks good on both desktop and on mobile. And the result here is going to be what you see for the left side for a desktop application and the right side for a mobile application. So if we bring up the text example here, or the example folder, I mean, we can bring up our main.go file. So this is what we have as a baseline. We create our app, our new window, and then I just have a username, a password, and a login widget. They're not that type of widget, but so the username and password are entries, of course, and the login is a button. And then I do the app.driver.device.isMobile function or methods to allow us to control different layouts when we have different, if we are desktop on or mobile. So if we just open up our example here, which I compiled it beforehand, we'll see that we have this section in the middle, and the widget can be this small at smallest. So how would we do to accomplish this? Let's start with a container .new grid with rows. So if you look at this, like, we have a grid with 3 rows. So we can pass this a 3. It's also worth bearing in mind here that we could just as well have used a VBox in this case, but using a VBox would have allowed the window to become this size as smallest. I prefer doing it this way, but you can do however you want. There are many ways to combine layouts. So we have that section figured out. If we have a layout.newSpacer, we'll get the this grid item to be a spacer. And then we can focus on this part. How do we do that? Well, if we see this as a grid with 3 columns, 1, 2, 3, we can do a container dot new grid with columns and pass a 3 into that. And inside this grid we want to have a spacer. And then we want this section. So if you think about this, we have a username entry above a password entry above a login button. We can use a VBox, container dot new VBox. So we have our username, password and login here, so we can take username and then we can pass the password and then we can pass the login button. So that's this part. Now if we want to, now we need a spacer in this part. And to round this off, we need this part. So let's see, where do we have that ends there? So we want container dot new, no, I'm just kidding, a layout dot new spacer. And of course that, I'll just pass that until then. So what do we have? If we run, let's first say we have the grid container with 3 rows, we have a spacer, we had a grid with 3 columns, a spacer, a container, VBox container, a spacer, and then ending out with a spacer. So if we build this, we have a layouts binary, and then we do layouts, and there we have the user interface all compiled and working. So the thing with using grids here is that if you had a VBox in this section, you would compress the username entries here and the button to be as small as possible, which would make them very hard to type, and as you expand the window they would not expand like this, and that is why I have a grid in that sense. But if we, for example, change this into a VBox, you'd see that it would build just as well, but it would be this small by default, but it would look basically the same, or it would look the same when you make the window bigger. So now on to the mobile layout. So this is what we want, and if we just think about this, we can use a VBox with a spacer, the username, the password, a login button, and then a spacer. So to do that, we just do new VBox, and then we, inside that, we put a layout.new spacer, username, password, login, and with that we can run go build tags mobile, and this is our mobile simulator. It works on Linux and Mac OS at the moment, I think. It does not work on Windows. It most likely works on BSDs as well. So if we run our layouts now, we get this mobile version. So that's the example of combining layouts to create a login screen that works good on mobile and desktop. Now, of course, you need to put this all into good use. So for the API reference of the layout package, you can check out the developer.fyne.io API reference site for it, which of course I see now should be 2.1. But I don't think the layout package has changed anything in 2.1, so you'll be fine. You can scan the QR codes above the top QR code for that API reference, and there's also a frequently asked questions section about layouts and widget size on the developer.fyne.io site as well, which you can use the below QR code for. So now I want to see your great layouts and how you can combine them. Thanks for listening.
Hi, and welcome back to FyneConf 2021. I hope that you're enjoying the day learning all about our toolkit. For the next segment, we wanted to take a new approach and have members of our community present the applications that they're creating. We have 3 people up, Bob, Charles and Michelle, who are going to take it in turns to explain what they are building and why Fyne has been a good match for them. Without further ado, I'd like to hand over to Bob, who is both a community member and a sponsor of the project. Thank you, Bob.
Good morning. My name is Bob Schaffner. I'm currently in Denver, Colorado in the US, and I'm here to describe my solution to my media problem. As you can see from this, I have approximately 250 gigabyte worth of digital camera files, scanned photos and slides, audio files, and videos that I've put together over the years. So what I have here is my solution, which is a media manager that allows me to put metadata on files or subdirectories and to create different views based on whether it's just a photo, if it's a subdirectory of photos, if it's audio files, MP3s specifically, or video files, MP4s, which what I'm showing here is the usage of VLC is my media player for video and audio. And again, this is just a command line interface for VLC media. I'll shut that off, and actually I'll go to audio. I'll say view, and this is a list of the MP3s that I have in this subdirectory. And we'll select one here.
Just take those old records off the shelf. I sit and listen to 'em by myself. Today's music ain't got the same soul. I like that old time rock and roll. Don't try to take me to a disco. You'll never even get me out on the
Let's see if
floor.
I can find the settings for it. What I really wanted to show is the capability to search. I have a simple query language that is basically a tag value, so I can say I want to see things in the year 2000. So each one of these is a photo that I took in the year 2000 when we took a trip to England. Or I could search for the year 2000, 2001. A wedding. Or I can search on any of the metadata. I can say location equal London. And these are all the pictures that I have referenced as a location with London. And I can also do an OR condition. Just by surrounding in an OR clause, it'll give me all the locations that are either London or have British in the name. So here's London. This is 2 of my daughters at the British Museum. This is our family getting on board the flight. Or I can search on any of these. I can search for $199, and that'll give me all the pictures I took in the 1990s. You notice these little stars, these are asterisks. They're special ones that I wanted to keep track of. So I can just look for favorites. And I can do a shorthand. I can just say favorite equal true. And it'll list all my favorites. Here again is one of my favorite daughters, with a big red nose, and dogs, and Roman bass, and a goofy mask. So anyway, this is my attempt at trying to put some order to the I forget how many digital files I have, but I think it's about 35,000. And I haven't even had time to index all of them yet, because that's another chore in and of itself, to be able to enter the metadata so that it's searchable. Yeah, I appreciate your time, and I love Fyne, and you'll love it too. Thanks a lot.
Thanks very much, Bob. It's great to see that Fyne is helping to manage that data of yours. Next, we're going to hear from Charles, who is a core contributor to the Fyne project. I hope you like his shirt and the project that he's going to describe to you.
Hello and welcome everyone. In this talk I'm going to discuss DE2 GUI, a tool that I wrote using Fyne to help us take a computer engineering lab course and move it into a virtual setting during the COVID-19 pandemic. So who am I? I'm Charles. I'm a PhD student at the University of South Carolina. I do research on high performance, embedded and reconfigurable systems. And on my free time I like to do some open source stuff. Fyne is one of the projects that I enjoy contributing to. And in fact, actually, I wrote Fyne's, at least the initial version of Fyne's storage repository system, which I'll be delivering another talk about at the same conference that you're listening to this one in. And when I'm not busy with those sorts of things, I'm also an aspiring home chef. As a disclaimer, any views or opinions that are shown in this talk are my own and are not representative of the University of South Carolina or anyone else. So what is DE2 GUI and why did I write it? So as a graduate student, one of my responsibilities is to be a teaching assistant for our Advanced Digital Logic Design course, which is where students design and implement a microprocessor using Verilog, a language for describing digital logic circuits, and then deploy it onto a DE2 115 development board. And normally this is very hands-on. These development boards have peripherals on them the students interact with, which I think really helps drive home the lessons that we're teaching and makes the class a lot more enjoyable. However, we had to go online because of the pandemic, as many other classes did, and so Fyne enabled me to develop a front-end, which I call DE2 GUI, for a Verilator simulation of the students' code, which allowed the students to complete their lab assignments virtually, as opposed to, having to toss doing hands-on labs and just do book learning or something like that, which would have been much less valuable to the students, I think. All the code that I'm going to show you guys today is open source. You can see the front end on this URL. And additionally, the 7-segment widget that I'll show in a moment is also upstreamed into FyneX, and you can view it at that link. So this is the development board that we normally use to teach the class. This image is taken from the manufacturer's website. As you can see, there's a number of different peripherals on it. The main one that we're interested in is the 2nd displays, this little row of LEDs here, these switches, and these momentary keys. There are also others, but we don't use that as much, so I didn't implement those in my GUI. And this is the GUI that I developed. So as you can see, I've re-implemented the 7-segment displays using a custom widget there at the top, as well as the LEDs, which are also a custom widget. And then I'm simply using the Fyne's off-the-shelf buttons and checkboxes to simulate the switches and keys. And implementing the custom widget was actually really straightforward. Just instance some circles and lines and kind of let Fyne do all of the heavy lifting of wrapping it up into a nice widget that you can instance and work with just like any other Fyne widget. So how does this work? During the normal version of this course, the student Verilog code is compiled to an FPGA bit stream and then uploaded to those development boards using Intel Quartus. When we're using DE2 GUI instead, we compile the student's Verilog code to a C++ simulation library using Verilator, which is another open source tool. I've then written a C++ shim that uses some extern C methods to expose necessary functionality as C method calls, which is needed because CGO doesn't know how to talk directly to C++. Finally, we write the actual GUI, which I showed the screenshot of, using Go, and then that calls into the student's code as a C library using CGO. So I'd like to show a brief demo. So first, I want to show off kind of what the alternative is. If we didn't have DE2 GUI, we'd be stuck with just a waveform viewer such as GTK-Wave, which is what I'm showing here. This is a really valuable debugging tool, but it doesn't have quite the same hands-on interactivity that we'd really like for our course. So now I'm going to switch over to DE2 GUI instead. So this is a live copy of DE2 GUI that is wired up to a simulation of a CPU that I've written, and it's running a simple test program that will read in a number off of the switches and display it in decimal on the 7-segment displays. So I'm going to go ahead and enter in the number 210, which is OXD2, and why 210? Well, because 2.1.0 is the next version of Fyne that's set to be released. So I've entered that in. So I can single step the CPU just by ticking one clock cycle at a time. I have a functionality that exposes simulated logic probes that help people debug their code, as well as a view of the CPU's register file. Can also let it auto tick and sit here and run along on its own, or we can just skip ahead to the end and tick a bunch of times. And as we see, it has in fact correctly converted OXD2 to 210. So that is the conclusion of my talk. Fyne made it really straightforward for us to take this course and make it online, and I think that, like lots of people teaching during the pandemic, there were many challenges, but at least the interactive aspect of the lab was not one of them, thanks to Fyne.
Thanks so much for that, Charles. It's really interesting to see that Fyne is able to help out in education. If anybody would like to make use of that 7-segment display, Charles has contributed it to the FyneX repository, which is a collection of extensions that you can add to your project as well. More information is available on the website. Next up, I'd like to introduce Michelle, who's going to talk about how she's been working in medical imaging and how Fyne has helped her to do that. Thank you, Michelle.
Hello there, my name's Michelle Williams, and I'm going to talk today about Fyne Daikon Graphics, a cross-platform medical imaging viewer. So I am a doctor, I'm a radiologist, and I'm also a computer programmer a bit on the side. And the problem I have is that most medical imaging viewers are large pieces of software that are inefficient to run, very expensive, often legacy and proprietary issues, and many of them only work on one operating system, only working on Mac, only working on Linux. Medical imaging is in the format of DICOM normally. So this is a medical imaging standard. It's a combination of pixel data and information about the images themselves. And this is the website, the dicomstandard.org. And with DICOM, all of these images that you can see on the screen have been made. So we've got a chest x-ray down here. We've got an MRI scan of the brain with 2 different types of sequences. We've got a CT scan of the chest showing the heart and the lungs, and then a PET scan, a radionuclide scan. And you can see that DICOM's capable of a lot of very complicated and very cool things. Now, one of the good things for this project is that there is a DICOM parser available in Go, and this is the one that we've been using. A DICOM parser takes different elements of the DICOM dataset out so that we can then use it in our program. So what are the requirements for this piece of software? Well, we wanted a lightweight medical imaging viewer. Around the world, different people have access to different levels of computing power. Some people in university hospitals like me have enormous computers that can power very complicated things, but in the rest of the world, maybe they only have an old computer, maybe they only even have their mobile phone. We also wanted something that worked on any operating system. It needed to be simple to use, without much, if any, in the way of instructions. It needs to be open source and easy to understand. And we want it to be able to be expandable with more features as they were required. We wanted it not to be restricted, that anyone could use it, and we want it to fully support mobile devices. So here's the solution. This is the Fyne viewer. As you can see, it's very simple and very quick to load and very easy to see what you do with it, with the buttons down one side and the image in the middle. So a word of warning here, this is not FDA approved, not approved by anyone else, and it's not suitable for use in patient care, but it is perfect for my research, where I want to be able to see images quickly, to process them, parse them, look at them, and do other things with them. So I do a lot of organizing images, annotating images. I use iPad, Linux, Mac. I want any of my students to be able to use this, and I don't want any restrictive licenses. I do a lot of machine learning research, and this is exactly what I was looking for, something really simple, quick and easy and multi-platform. So here's a couple of examples of the important things that this does. So first of all, we've got looking at an axial data set going through a slice. So here you can see us moving down through the image of a head. And this is the first thing you need to do when looking at any 3D structures. We're looking down through all of the slices of data in our image. And this is the second really important task that we wanted it to be able to do, windowing. So with DICOM, we have more information in terms of pixel data than the human eye can possibly parse and process in terms of grayscales. So we have to use subset of the grayscales to bring out aspects of the imaging in different ways. So some of these are useful for looking at bones, some the lungs and the soft tissue, and some other structures within the body. So we use lots of different windowing levels. So these are the two really key tasks for a medical imaging viewer, moving through the data set and changing the window level. So why Fyne? Well, it's very quick to build with. This was constructed with its basic system in less than a day. It's clear and maintainable code. You can understand it by looking at it. So if I want to add in other things, as I have other tasks that I want to do, I can do this pretty easily. It looks great out of the box. I didn't have to do any of the design aspects. It was instantly look good, and it works on anything, and this is crucial to me. Mac, Linux, iPad, they're all part of my day-to-day life. Go is also a really good language with a fantastic community, and it's easy to use for writing GUIs. I spent a day learning it and getting myself up to speed, and it's been a really enjoyable thing to use. So our future plans. We want to use our FyneConf viewer to look at images in lots of different ways. So axial, going down, up and down through the body is one way, but we also want to be able to look sagittally and coronally through the body, so looking at it from the front or looking at it from the side. And we also want to be able to look at it from any angle. So some data sets like CT scans are a three-dimensional data set, so to be able to look at it at oblique angles would be very useful. We want to be able to draw regions of interest and segmentation and annotations that I'll be able to use in my machine learning work. So here is where to get the DICOM viewer on the Fyne Apps website. That's the link to it here. And if you'd like to contribute, here is the link on GitHub. So thank you very much. Please reach out to me on Twitter at ImagingMedSci if you have any questions or suggestions. It's been fantastic to work on this project with the Fyne team. And a final thing, all of the images that were used in this presentation are free open source DICOM datasets that you'll find on the internet. Thank you very much indeed.
Thanks very much, Michelle, for the introduction to medical imaging. I hope that Fyne continues to make it easier to get access to and visualize patient data on the go. Thank you also to all of our speakers today for this new segment on My Fyne Apps. I think it's really great as the project continues to see how people are managing to use it in various different ways. If you would like to find more applications that have been built using Fyne, I would recommend that you go to our apps listing website at apps.fyne.io. Here we have a listing of many applications that have been contributed from people across the community. They're all free and open source, so you can download them, try them out, but also follow links to their original source code, learn how they were built, and perhaps even contribute to their future. In the menu on the website, you can find links to different categories and so forth, but also an item highlighting those applications available on Apple's store and the Google Play Store, so you can follow through on your phone or tablet to download applications directly to those devices. Thank you to everybody who's contributed their application to the website. If you would like to see more applications on your computer, we also have a helpful application that will be able to manage your installed software. If you haven't already, first get the Fyne helper command installed using go get fyne.io/fyne/v2/cmd/fyne. That will be useful for various application development as well, but here we're using it for its own get command, which downloads the code, bundles it up into an operating system application bundle, and installs it into your computer as a desktop application, instead of how the go get command would install it as a binary on the path. Once this has been run, you can launch the apps application, and it will look something like this. It's accessing the API through to the same website and will allow you to browse various applications that are currently available. They're listed on the left here, and explore what is available to offer. This is the Notes app, which I already have installed. I could have a look at other things. There's the DICOM viewer there, which you'll remember from before. There are some classic games, such as Fine Sweeper, always a classic, and other items that you might have a little nostalgia for, but also utility applications like a terminal. If you see an application you like, you could just tap the install button, and it will go ahead and make the necessary compilations to get the application installed on your computer. And there you see it was successfully installed. In this way you can access each of these applications and have them download and run on your local computer without needing to go to the website and making the compile commands yourself. Hopefully this will help to find lots of Fyne software available and also manage it on your computer, keeping applications up to date and finding what's new. If you like what you're seeing here and you would love to get your own application added, you can head along to developer.fyne.io/submit and provide your information to have your open source application included in the listings. We look forward to seeing other applications that are being built out in the community, and thank you for your time to send us information about what you've been building. We're going to take another little break now, and we'll be back shortly to see Charles' second presentation about the storage repositories that he created and how they've evolved over time and how you might find them useful in your application. We'll see you then.
Hello and welcome everybody. In this talk, I'm going to discuss Fyne storage repository system. So who am I? I'm Charles. I'm a PhD student studying computer science at the University of South Carolina. My research focus is high-performance, heterogeneous, reconfigurable, and embedded systems. I'm also an open source enthusiast when I'm not busy doing my PhD research. Fyne is one of the projects that I enjoy contributing to. And in particular, I wrote the original version of the storage repository system we're going to be discussing today. When I'm not busy with those things, I'm also an aspiring home chef. And if you'd like to know more about me, you can visit my personal website at the link in this slide. As a disclaimer, views and opinions expressed in this talk are my own, not those of the University of South Carolina, the engineering department, or anyone else. So to start off with, kind of what's the lay of the land here? So applications written in Fyne need to access data. Most of them wouldn't be very useful if they couldn't. Sometimes this data could be on disk, like a file that you might think about in a typical desktop application. But also sometimes on disk doesn't necessarily mean you can access it with os.open. One of the motivational reasons why we implemented storage repositories in the first place was because a lot of mobile file access is mediated by these special platform-specific, generally URI-driven things, like if, say, the user has shared a file with your application through their share menu. Or maybe it's part of some other application that's exposed through an OS-specific API, but not just as a normal file on disk. Also on a deeply embedded system, like, say, some kind of kiosk where everything is stored in some kind of read-only memory or something like that, it might be advantageous to be able to bundle all of the files that you need into a single archive, things like that. Additionally, right, your data that you're interested in could be somewhere else completely different. It could be on the web. It might be part of a cloud storage service like, Amazon S3 or Dropbox. It could also be in an archive file, like maybe a zip or a tarball, something like that. And we'd like to make it really easy for developers to work with data from all of these sources in a simple and consistent way when they're developing their applications. So our design goals when we set out to create the storage repository system, kind of the first one was to be able to support mobile platforms. That was kind of the initial impetus that put us down this road, and especially being able to handle things like shared files and stuff like that. But we also wanted to be able to support any kind of file-like device. So for example, maybe you have an HTTP or HTTPS server, a zip file, Amazon S3 was a motivational example we came up with. You could imagine lots of different data sources that are kind of hierarchical and have kind of nodes that you could read or write data to. We'd also like to be able to make this solution extensible so that we can support use cases that we didn't specifically think of in advance. We've tried to make the API very flexible so that we don't want to hem people in and prevent them from molding it to fit their needs. We'd also like to allow for backend specific optimizations. So for example, if you're using a move operation with, say, Amazon S3, rather than downloading all of the data to the client and then uploading it back to the server again in a different place, it might be faster to use some kind of specific, remove command that makes that happen on the remote that might be faster. And so we've tried to expose API endpoints in such a way that the developer can just use a generic implementation where maybe they are pulling all the data down and writing it back out, without preventing them from being able to use an optimized version if one is available. So the history, this kind of started in August of 2020. We initially were running into the trouble that we needed a way to have cross-platform directory listing support with our existing URI implementation. And as we implemented that, we kind of realized that the URI system that we had at the time wasn't really flexible enough to handle everything that might come up in the process of dealing with files and file-like data when writing any kind of application. So in December 2020, which was my winter break, until kind of the mid-January, we developed this proposal, and these are clickable links if you download a copy of the slides. And if you can't, this proposal is in the wiki for the Fyne GitHub repository, and the numbers here that are in blue are either issue or PR numbers for that, in case you're interested in following along at home. And so in that proposal, that kind of doubled as a beta test for the proposal process that we now use for all of our proposals. And there was a lot of discussion about what we should do and how we should do it. This kind of turned into one of those problems where as we kept coming up with different ideas for how to approach it, we realized, wait, no, actually there's this use case that we want to support that this model doesn't work with. And so we iterated for quite some time, but eventually we settled on a model that I think works really very well, and I think everyone was pretty satisfied with. So I started this work in a PR in December, which was PR number 1665, and then we also ended up having to do a second PR, which was 1768, which got merged into the develop branch in January of 2021. This was one of the biggest open source contributions I've ever been a part of. There was a lot of discussion and going back and forth with the core team, and quite a bit of code as well. It was 116 commits, 305 comments, 15 printed pages worth of proposal, and 2.8 thousand lines of code. So let's start diving in a little bit deeper. How does Fyne handle I/O, which really means how does the storage repository system work? So we have this concept of a URI, which is the hydrated version of an RFC 3986 URI string. So it could be something like file : / something.txt, or it could be http : / example.com, something like that. And kind of in our model of the world, this represents a reference to a resource that's kind of namespaced by the protocol that's kind of stuck on the left-hand side of that URI. So we'd say, and that's handled by a repository. So, for example, right, a HTTP URI, we would say is a reference to something that's in the HTTP repository, which is this, monolithic blob that handles all URIs of that type. Now, and internally, it could delegate to, several different systems depending on the contents of the URI, but that's an implementation detail. So minimally, we have to know how to test the existence of a URI, and we have to know how to open a reader for it to read whatever data is referenced. Additional capabilities can be implemented a la carte by a repository, which we'll talk about in detail a few slides later. So for example, if the repository that you're working with allows for modifying data, there may be endpoints for obtaining a writer as well, or for creating a new empty file or something like that. So the repository object essentially tells Fyne how to work with URIs of a particular type. So, right, there may be some abstracted endpoint which is in the storage module that could be something like, open, right? It might get a reader. I actually don't think that API endpoint is called open. That's on a later slide. But what that actually does is, under the hood, it's just calling into the storage repository that's been registered to handle the file protocol. And you can register repositories at runtime. By default, you get the file one that's kind of set up out of the box. And I think as of 2.1.0, I believe HTTP will be set up and registered out of the box. But you as the end developer, right, if some third party has developed a storage repository that you want to use, you can also pull that in at runtime, no problem. And so, yeah, like I said, calls to methods in storage internally, right? It's just checking that protocol that's in front of the URI and then delegating it to whatever appropriate repository has been registered to handle that. So how do we know which features a repository supports, right? Because, say, like a file, right, you could read that or you could write that, but maybe in HTTP you can only read, or maybe you have a read-only zip archive and you can only read stuff, you can't write stuff, or different things like that. Or maybe you're doing some crazy data model we didn't anticipate where getting directory listings doesn't make sense. So we do this using type assertions, actually. The code here I have on the right actually is taken right out of the storage repository code, or out of the storage module in particular. So this defines the process of getting a writer, and all we do is we say get the repository for this URI, which is just doing that lookup based on its protocol, right? So like file : / would be a file repository, and then we try to cast it to a writable repository, which is just an interface that defines certain extra methods above the baseline repository type. And if we fail to do that, then obviously this isn't a writable URI and we can't obtain a writer. So we return an error that indicates it's not supported. So for example, in this case, a writable repository, that interface means that you have to know how to get a writer, which returns a write closer, which you can use with all your standard IO util methods that you know and love. Can write, which is just intended as a performance optimization, because on some systems it may be faster to check if you can write to something rather than trying to do it and seeing if it fails, and then delete, which as opposed to just overwriting it with just an empty byte string, right? That actually kind of, in the context of a file system, for example, would remove that node from the file system. Now, whether or not delete's meaningful in the context of a specific repository's kind of implementation defined, but on a file system, right, delete does exactly what it says on the tin. So what repository interfaces are available right now? There will likely be more in the future as we see how the community utilizes these capabilities, but these are the initial ones that we've set up for kind of the first go around of getting repositories going. You've got your baseline one, just called repository. Everybody has to implement this minimally, and this provides your exist reader can read, right, which essentially checks for read permissions and destroy. Custom URI repository allows you to override the URI parsing routine. So if you have something that's not compliant with the RFC, which we know that some maybe vendor-specific APIs may not be, and so it can be useful to be able to do that yourself. Writable is for things you want to be able to mutate. Listable means that you can obtain something analogous to a directory listing. May not always be the case for every type of file storage backend. Hierarchical means specifically that you can get the parent of a URI, and also that you can create children, or at least attempt to create children of a URI. And you might go, well, aren't all URIs hierarchical? And yes, per the spec, but that's not necessarily true in terms of how people have actually implemented them, right? So if you have, some magical proprietary API : / a big base64 blob, that internally on some vendor's backend might mean something significant, we might not know how to create a parent or a child, or thinking about the parent or the child might be some other horrible base64 blob and not something that semantically equates to a parent or a child as we think about it, like with a file path of saying dot or / child name. Copyable repository allows you to implement copy. We have a generic version of that you can use if you don't want to implement an optimized version, and our generic one just reads all the data as a reader, obtains a writer, and writes it all back out. And movable is analogous. And all of these are available in storage / repository / repository.go in the main Fyne repository. And they're all commented and documented, so if you're interested in learning more information, you should give that a look. So what repositories are available right now? So currently all of our official repositories are in internal / repository, and specifically file and HTTP get added automatically to apps at startup. File was added in the initial version of storage repositories that released with 2.0.0. HTTPS support and HTTP support have recently been added in PR number 2239 and are going to come out with 2.1.0, which, barring any technical hangups, will probably already be out by the time you're listening to this talk. We've also got a mim : //. We haven't made that available as a public API yet because it's not quite in a state that we're ready to commit to supporting it. But we use this internally to simulate a file system for a lot of our test cases, and I think we'd like to make something like that available as a public API in the future once it's more tested and more robust. And of course, more to come, and obviously the community, we hope, will also write some as well that may facilitate the projects or use cases that they're interested in. So why did we design storage repositories in this way? We wanted developers to be able to use just a single set of API endpoints in storage, not having to use interface methods, right? For example, we had originally thought, we'll just add this to the interface type, but then that now means that everyone that wants to implement a storage repository, which we hadn't really quite coined that term yet, now has to implement all of these interface methods on all of their URIs, and a lot of them are going to be redundant, copy-pasted boilerplate, stuff like that. So that's kind of why we ditched that and decided to just make them be regular functions in storage where you give it a URI as the first argument. And we really want to make sure everything just works really smoothly for developers on the happy path. If you're just using a file dialog or something like that, in kind of the intended way, it should hopefully be really simple and straightforward and not have too many footguns. But we'd also like to make it so that if you want to do something that's not on the happy path, it's still possible, and we're not constraining you from being able to do that. Also, we want to make it so that a library or application that's using our storage API will also work automatically for free with future, as of yet unwritten storage repositories that we don't even know about yet. And the way we've designed it, you can do that. You'll be able to, if you write an application now, and next year somebody implements a Dropbox storage repository, your application will just work with those URIs for free, assuming it's been registered appropriately. Also, we can add new repository interfaces to expose new functionality, like maybe we wanted to have a get compressed reader or something that reads some kind of transparently compressed object. We could add that without breaking existing code or existing repository implementations, because that would be a new repository interface type with a different endpoint and storage and a different type assertion. So all of the existing code would still keep working, and library authors, especially repository implementers, wouldn't have to do any work in order to get their code working, or to have it continue working, I should say. So now let's take a look at a code example just to kind of maybe drive this home a little bit. So this is just a little simple application. It's going to pop up, let us enter in a URI, and then it's just going to read that URI as text and show it on the screen. So we're just going to drop all that in a label, and we'll create a little entry that the user can put their URI in. Now, of course, normally as a developer, you're not going to be creating something where the user is dealing with raw URIs. You'll be calling into something like the file picker or something like that. But for this simple example, it'll be fine. We got some error handling. This will be the callback that is called when we want to enter our URI. We show a little form that the user can type that URI into, and then this function here, starting on line 39, is kind of the real meat and potatoes. So first we get this, textual URI. Now, if you were getting this back from, say, the file picker, it would already be a hydrated URI and you wouldn't have to parse it. But since the user's entering a string here, we have to parse it because it might not be valid, right? So we do that, throw an error if it's bogus. Then we get a reader for it. Again, that could fail, right? If it's a non-existent file or you didn't have permission to read it or something like that, it could have a valid URI, but there might not be anything on the other end of that reference. So we try to obtain a reader, throw it away if we didn't get it. Finally, we just read all of it, and I do want to emphasize, right, we're just using ioutil.readall. So if you had code that was already using like ioutil or other Go packages that work with things like readers, all that'll still work pretty much in the same way. So we do that, and then we overwrite our main label with our text, which will mean it'll show up in the middle of the window. And then the rest of this is kind of your standard boilerplate that creates a menu, wires that menu up, makes the contents, take that main label and whack it in a little scroll container, resize the window, all that good stuff. And by the way, just for documentation purposes, this was written against Fyne 2.1.0 RC1. So I would reasonably expect it to still work against Fyne 2.1.0, barring some unforeseen technical snag. So now I'm going to switch over to a little video showing this code working. So here's our video. I'm going to hit play. So I go up there, enter my URI. This first file is just one that I created for this demo. It's just got some dummy text in it. And there you go. There's the contents of our plain text file. And then as another example, I'm going to enter in my personal website, which is going to be an HTTP URI. And we'll see that it'll pull that down. Of course, that's going to be raw HTML. But as we can see, it did in fact pull that data down. And ioutil.readall doesn't have to care. All right, let's switch back to our slides. All right, so wrapping up. The storage repository system allows Fyne to abstract access to any kind of file-like resources, which includes files. It now also, as of late, includes HTTP and HTTPS, and in the future, hopefully, will include much more. As those new repositories are added in the future, existing applications will basically get more functionality for free without having to do code changes, or at most, right, maybe pull in an extra dependency and register a repository. All Fyne APIs that deal with any kind of files already use storage repositories internally. They pass around URIs. So if you're kind of sticking on the happy path and using only the official APIs, all of this should kind of just work transparently with hopefully very little cognitive overhead. Additionally, new storage repositories can be loaded at runtime, which means that Fyne, including our internal APIs as well, but also third-party libraries, can access storage backends that their authors never accounted for, right? So if you write a storage backend that's specific to Google Drive, you can pass that to Fyne internal APIs as long as it's a URI and you've appropriately registered the repository, and they'll be just as happy to work with that as with a local file. All right, thanks for watching my talk.
Welcome back once again to FyneConf 2021. In this second community segment, we're taking an opportunity to give you a sneak peek in some of the work that's currently going on behind the scenes. First of all, I would like to hand over to Jacob, who's going to talk about packaging through Flatpak.
Hello everyone, and welcome to my talk about Flatpak, and more precisely, Flatpak your Fyne app. My name is Jakob Alsen, and I'm going to talk about a modern packaging format and how to package Fyne apps for it. Now you might ask, why Flatpak? Well, let's first get to know what it is. And Flatpak is the next generation technology for building and distributing desktop applications on Linux. And in general, it's a modern packaging format that allows you to build an application once and then run it on any Linux distribution. And this whole format, from top to bottom, is 100% free and open source, unlike other packaging formats such as Snap, which is the main competitor to Flatpak. And a very big part of the benefits of using Flatpak is also that all the applications run inside a sandbox. And this means that the applications have like a layer between, which prevents them from accessing certain parts of the host system. And it also has the benefit that you can control permissions, similar to what you do on, for example, iOS and Android. And here you see an example of Warmall GUI changing permissions for it inside the GNOME settings application. And part of the benefits of Flatpak working on any Linux distribution is that you can install a wide range of applications. And currently the biggest application store for Flatpaks is flathub.org, where you can find hundreds, maybe thousands of applications. Now, let's get into building our Fyne app for Flatpak. And first of all, we need a manifest file which we can use to control the build. And in this case, it's a YAML file that should have the name of the app ID of the application. And in this case, in our little example, it's io.fyne.flatpak_demo, which you can also find on the Fyne.io organization. We want to use the runtime, the regular free desktop platform with the latest version, and then use the SDK when we're building, and then we need an SDK extension for Go so we can compile our Go code. And then we also need a couple arguments to specify what parts of the system that this application will need to access. And this is where build requirements come in. We need IPC share for better X11 performance, and X11 so we can render applications on the screen. We need the direct rendering interface device so we can do OpenGL rendering support. And if you use the Fyne preferences or the new document storage APIs in Fyne 2.1, you'll also want the fourth line there under finish args for giving access to the Fyne preferences folder. And there it is important in this case that you use the same app ID as you do in app.new with ID when creating your Fyne application if you want that fourth row to work. It's also worth noting here that no network access is enabled inside the build containers by default, or when building, I should say. This means that you need to work around that in some way, and I've personally found the best way to enable vendoring and then commit the vendoring to the GitHub repo, and then it will be included inside your archive that you download from the release on, for example, GitHub. It's also worth noting here that we need upstream meta info to provide information about the application, screenshots, description, summary, and that sort of things. We also need a desktop file which we can include inside the operating system to launch the application, and of course an icon to show off our application. And these, you'll find the install command there, it's all in the example. And then we just want to fetch the archive from our release and then get the SHA-256 hash from it. Then it's also worth to reiterate this with the sandbox, with the runtime requirements. We want minimum system and hardware access by as long as it's possible. We don't want to expose more features through the sandbox than we really need. This is why this example, in the upcoming example, I have just exported the documents folder. If you don't need access to webcams and such, don't enable it. And again, look at the demo there, find a lot of instructions on how to build. Speaking of building, with the following command we can build and install the Flatpak in one step. And if we look inside the GNOME software, we'll find that the application is available locally with all of the information from our meta info file, and that's that, I should say. Now, let's do a little demo. As I said before, I've just opened up the documents folder for this example, and that's why we will see now that when I open the file manager, or file dialog I should say, that we just see the documents folder in the home directory. The sandbox doesn't give any other access to our application. We can see the contents of the file in the computer directory, but we can't edit them. And if we go into the document folder, we have an example.md, a markdown file. If we open that, we'll see that our application launches with all the contents, and it's using the great new markdown support in Fyne 2.1. Now let's talk about the next steps when it comes to Flatpak. First of all, we of course need to publish the first Fyne application on flathub.org. And then there are a few improvements that we can do to the Flatpak support in Fyne. For example, right now, notification seems to not be working. For that to work, we most likely need to use something called a portal, which opens up for secure communication through the sandbox. And we can most likely use another portal to improve the file handling to avoid opening up all of the folders necessary for an application and just letting a user choose which file they want to permit to go through the sandbox. And we'll also of course want to show Flatpak supported applications on apps.fyne.io, just like we do with Android and iOS apps at the moment. That was what I had. Thank you everyone for listening.
Thank you very much, Jacob. I hope this makes packaging and distribution for Linux systems a lot easier over time. And next up, I'd like to introduce Cedric, who's going to talk to us about the much awaited delivery of Fyne applications through a web browser.
So, hello everyone. I'm going today to be presenting about WebGL and WebAssembly. I'm Cedric By, and I've been doing C and C++ development for decades, and now I'm doing a little bit of Go for fun. My GitHub and my contact us here, don't hesitate to reach out if you have any question. So why a web port? It does provide a quick access to a preview experience of Fyne application. So you could easily get user to kind of check it out, what it will be. The ease of deployment, update, and reach to customer via the web is still way better than other method. So there is that zero installation, last version up to date access. Hopefully it will be fast enough for most people to be able to use it. But that's why I'm kind of saying it's a preview experience, because I still think it will be still better to go native in most cases for users in terms of ease of experience. But the web technology are evolving very fast, and they're aiming to deliver high-end application experience. So it's really something where a Fyne application should just work. And so I've been working on my spare time, and I've done most of the work maybe 2 years ago for getting Fyne demo to just work out of the box. There is a lot of detail that we're out to get, but here we go. Here we are. So what are the technology that we're using for making Fyne working on the web? We're using WebGL. It does require a GPU, but it does provide basically OpenGL in the browser, which makes life really easy to make it working. The also nice thing is that WebGL work on most smartphones these days, so you can actually try your web app version of your Fyne app on a smartphone, and it will also work there. The other technology that we're using is WebAssembly. WebAssembly is very cutting-edge, evolving ecosystem, and it does allow for compiling from native language to the web and run things really fast enough. And it's not as fast as native. It does have a few technical restrictions on what you can do, but it's really usable, and a lot of code can actually be straight used from native world into the web world thanks to WebAssembly. So that's a pretty cool. A lot of all the major browser these days kind of support it, so it does enable a lot of possibilities there. So Fyne demo on the web. That's basically what it is. The main blocker has been for years that the resize of the window was not asynchronous, and there was it was hard to get it right. That was unblocked a few weeks ago, and so it's now time to get that PR back in shape and get it landed in Fyne. There is a limited feature support at the moment for Fyne, so like file selector, no multi-window. Detail like that, and I'm not really iron, so it's really a tech preview at this point. But in time, most of this limitation should be lifted and should be working nicely. And I've set up a temporary website for demo there that you should be able to just check Fyne demo at that fyne.zlm.me address. By the time you are able to see this video, hopefully I will have updated my website, and it will be the last version. But this one is Fyne from 2 years ago, so you can see it has Fyne. If you look at Fyne demo today, it has changed a bit, but nevertheless, it's just working. You can see that you have animation, you have icons, image, and things are there. There is still some work to get things ironed out, but it's looking good. And so that's how I will conclude my talk. And have a good day, everyone.
Thank you very much for that, Cedric. I can't wait until we're able to help people get their applications delivered through a web browser as well. For the last section of this tech preview segment, I wanted to share with you a work in progress to do with cloud integration that's been part of our development over the last few months. Before I get in, I need to note that this is to be taken with caution. It's all heavily work in progress, and it's not really part of the main project yet. But with that, why would we want to be looking at cloud? Well, as the diagram illustrates here, it's about having all of your files available to all of your computers. Fyne is already available to be deployed on all of those devices, so it makes sense that we would want to make the files as easily available. Like I said, the applications run everywhere, but the data is currently local to the device that you're running on. At the moment, people are working remotely. They might be on home, on the train, or back in the office. Where are your files going to be? Well, this is part of our belief that users should have access to their data wherever and whenever, and that's where cloud comes in. There are de facto standard platform providers already, but they've not yet been integrated into the Fyne ecosystem. And we think it should be just as easy to integrate cloud data into your applications as it was to build your first GUI using Fyne. And so on to the API design. We wanted to keep it simple, and at the heart, it's about a provider advertising what it's capable of delivering to an application. So here you can see we've got two illustrations, a cloud provider that can deliver preference storage, and a cloud provider that could deliver storage of documents as well. They basically describe two methods that would be required for a cloud provider to implement. And you'll notice there is a common element on both called cloud provider. This cloud provider API is really about metadata, something that enables each to identify itself to the user, and you'll see why that's important a little later. But how does this get wired into your application? Well, there's one more line that's going to be important. Application has a new function called set cloud provider. And so if your application connects to a standard backend and you're the developer of that, you can implement a wrapper for that provider and hook it in exactly here so that your application uses the provider that you've configured for preference and document storage. However, that's great if you want to deliver a specific backend, but what if users look to choose? So we would like to enable as well, so that developers can enable cloud storage without necessarily controlling where that cloud is. Users would then be able to choose their provider. This data would be stored globally to the user's desktop or device, and it would apply to all cloud-enabled Fyne applications, which means you set it up just once and it's going to work for all other applications that you install. It moves the cost of delivery off the developer because they don't have to build the infrastructure to the user who may choose to sign up with a new provider, or they might have one already set up on their computer or an account on a provider that they're going to choose to use. And also, this is really minimal effort to activate. In fact, instead of needing to build any functionality, any infrastructure, or even any wrappers, you simply add one line of code into your application, cloud.enable, passing the app object. And this is going to set up all of the information that the application is going to need to utilize cloud functionality. There will be the option for users to make their selection configuration of the cloud infrastructure through a separate application. But if you would like to be able to hook in some user configuration inside your application, then that's going to be supported, perhaps in this manner, where we have a sync option in the file menu of the application. That would open a settings dialog for the cloud, and that will look a little bit like this perhaps. The user can choose which cloud provider is going to handle their storage and potentially configure it as well. That's what the API looks like and how we're hoping to deliver it. But why don't we have a quick demo? To demonstrate the current functionality in our cloud work, I've got an updated version of the Notes application. It's been updated with the cloud integration, and the menu has been hooked in as demonstrated in the code earlier. You could see that this has a file menu with the sync option. If we click on this, it will load the dialog that allows us to choose our cloud provider, using the theme of the current application, of course. On the other window here, I have a remote connection to another computer, which is running the same software in light mode, and this has the same setup, and I could go to the file menu and set up sync on this one as well. And what you will notice is that the content is the same. When I go to edit something on one copy, we see after a small delay the same information popping up over here. Whether it is the currently editing note or something else entirely, like this second one, the data is going to stay up to date and propagate across all of my computers and instances of the Fyne application automatically. So there you have our cloud integration work in progress. There's still a lot more work to do. I just thought I'd outline some of the next steps here. We absolutely want to add more standard cloud providers so that developers choosing to let the user select their provider have a larger list. We're currently working just with Dropbox, so there's a lot more to come. There's more to be added in the API. The document storage that came in 2.1 isn't yet propagated over to the cloud work in progress, so that's definitely next step as well. We're going to want to work with lots of developers who would like early access to this functionality to make sure that we're getting things right, that latency isn't too high and that functionality is just exactly what they would like. And then we want to work with more cloud providers to see if they would be interested in adding more integrations that were either part of the user choice or available to developers so they could set that up for their projects. And then of course we need to choose a feature release. It's not been decided yet when this will be made available, so why not work with us on that, and it might be available sooner. Thanks everybody who contributed to this tech preview section of FyneConf. We're going to take a short break and then we'll be back with the wrap up of the road ahead, where this project is going, and we will see you then. Hi, and welcome back to FyneConf 2021. We're in the home stretch now, but before I move on to the road ahead, I just wanted to thank very much the fantastic speakers and presentations that we've had today. I hope that you've found something to learn and will take away into a future project. But before we wrap up, let's just have a look at what's coming around the corner. First of all, I would like to start with the current projects. This is items that we currently have in work. You've seen earlier today the WebDriver and our experiments with cloud integrations. Hopefully they will be coming along nicely. Also in progress, we have rich text editing. You saw today the new rich text support, but full editing is going to take a little while longer. We also have some work underway for supporting drag and drop. That's not just inside applications, that's already working, but to integrate with the operating system, to drag files in and out of your Fyne windows, and on macOS to be able to launch your application when somebody drops a file onto your icon. Also, we continue to work on FyneDesk. For anybody who's not familiar with the project, it's a new desktop environment for Linux. It's written using Fyne in pure Go and is bringing new life to the desktop with some code that hopefully everybody who's familiar with Fyne will be able to get involved in if they would like. And lastly, the Fyne Labs team have been working on a new operating system based on the FyneDesk project and other applications that we've been working on. But let's just talk a little bit more about that. It's a brand new project and I suspect that you'll not have heard about it yet. We're building on top of the Debian GNU Linux system, and we're designing something that's going to be really light and fast, like a lot of Fyne applications are. Most Linux operating systems have started to include a lot of dependencies and things that you might not need, and we're trying to take it back to its roots, but giving a great experience all the way through to the desktop. Like I said, it includes the FyneDesk desktop environment, which we have presented at previous FyneConf events, and the newly created Fyne login manager, which is what you'll see when you boot the FyneConf operating system. Optionally, if you choose to have a development-focused installation, we're going to deliver the Define IDE, which is another piece of work in progress. These are going to be accompanied by other development tools so that FyneConf Developer Edition should be the best place to work on your Fyne applications, and it will have all of the tools to distribute to absolutely every platform from one operating system. If you would like to learn more about that, please head to fyneconf.com and keep an eye on the website as we add new information there going forward. So that's what we have going on, but what about future releases? Well, the next release that we're working on is currently codenamed Bowmore. We don't yet have a release version set for it, but it will probably be 2.2. We started to use code names instead of version numbers so that we can pick the appropriate version number based on what content ends up being included in the release. So Bowmore, we're hoping, is going to include the WebDriver that you saw Cedric presenting earlier. It hopefully will also include the rich text editing. So that will mean that you can write a full rich text editor rather than a text editor with a rich preview, as was demonstrated earlier today. The drag and drop support that I mentioned should be included as well. There are a couple of operating system specific concerns to iron out, but that should be with you when this release comes out. We're looking to extend our input widgets to include date and time as well, so that you can pick something from a calendar or from a clock type input widget. That should round out the different types of form components that we've currently delivered. And we're also going to work to complete Wayland support on Linux. If you don't know about Wayland, that's fine, but if you're working with Linux software, you may be familiar with X11 versus Wayland, and we currently support only X11 fully. There's a Wayland preview in there that we haven't really mentioned too much, but we're going to finish that off and add it to the officially supported list. And lastly, to go along with the enhanced theme capabilities we've been working on, there's hope that we'll be able to make this even easier by loading that data from a file or from a string, and that might be using JSON or TOML resources, TOML being the markup that you saw earlier for the metadata file. So if you have thoughts on any of those items, do reach out and help us to shape those features into Bowmore release. That should be with you early next year. We're hoping that that won't be too much longer because most of the large pieces are already underway. But further afield, we don't know what code name is going to be tagged for this release yet, but version 3.0 offers us another opportunity to make some changes to the API larger than the current backwards compatibility guarantee constricts us to. It's also a chance to rethink how certain items work, and that broadens out what we can do. The biggest thing that's been asked for us a lot is for multimedia support. There's challenges involved there, so we've not been able to deliver it just yet, but we're hoping that this big jump forward, whenever it occurs, will be able to include audio and video support. The big item would be internationalization. We also have a lot of requests for this from people, especially in China and Japan, and with a little bit of help, I'm sure that we can make that work as well. There's a real challenge around how can we keep these applications slim, but still support different languages right out of the box. We also would like to support accessibility properly all the way through every widget. That's a large amount of work, but if people have experience in that area, we would definitely like some help making sure that we get that right as well. Navigation containers and standard app skeletons. These are two items that are going to be really helpful to assist people building more complicated applications quickly. We love that our API is simple and that you can get running really quickly, but sometimes when you're looking to pull lots of different features together and have a full application running in the first few hours, it can seem a little daunting. And so there are going to be standard pieces of functionality that we can pull together into templates or other APIs that will make that a lot easier, especially for conforming to certain application types, like an editor that can open multiple files and wants to look as expected on desktop and mobile platforms. We would also like to improve the mobile support to include Linux-based devices. Now this is not Android, they've been there for quite some time, but things like PinePhone and other operating systems that work on top of Linux but have certain special features and functionality that make it work really well in a mobile environment. There's a lot of devices out there for us to test with. If you have one, do get in touch. And lastly, it would be really great at that time to deliver some enhanced visual debugging tools. This is something that can currently be a little bit of a challenge. The Go debugger and standard tools are fantastic for learning how the code works, but sometimes it appears on screen and something's not quite right, but you're not entirely sure what that is. So we're going to be adding functionality that enables you to look at the screen and understand more about what's happening. Things like where are widgets, where are their boundaries, and also how many times is something refreshing. You might call this hotspot tracking for the graphics pipeline, for example. So all of these things we're hoping to have with you in the 3.0 release whenever that might appear. Items could potentially come in earlier releases, which would be fantastic. And if you would like to get involved, well, you can. And here's how. Firstly, the key links for learning more about using Fyne. If this has been your first FyneConf or the first time that you've seen the toolkit, this is the place for you. The developer.fyne.io website is going to get you up and running really quickly. All of our documentation, tutorials and run-throughs are there. If you prefer video learning, then we have a YouTube channel, and that's going to be refreshed over the next few weeks as well, updated for all of the new APIs that have been coming out this year. If you would like to contribute to the project, and we would really love to have you involved, please do. We're looking for people to help with the coding, to test, to document, and also to help us improve the design. Any type of contributions are all managed through our GitHub project. You can see the link there. And there's documentation in the wiki about different processes that we follow and how you can best get started. Of course, you can sponsor us as well. A big shout out to all of our sponsors. They're listed on that website there. Thank you so much, everybody. There's no way that we could deliver this project and indeed this conference without your help, support and encouragement. If you'd like to be involved, please do consider helping out with sponsorship. There's a few goodies to be earned at different levels of sponsorship, and that warm feeling knowing that you're part of helping move this project forward. And lastly, if you are considering using Fyne in your business and you would like some more committed support than the community, then you could consider talking to Fyne Labs or other companies around about the Fyne toolkit. So far we've heard that the support available in the community is sufficient for a lot of businesses, but if you're looking to roll this out into production, you might want to speak to Fyne Labs instead, who can help you take it to the next level. Before I let you go, of course, there is the book raffle. I'd like to thank Pact very much for their contribution of 10 copies of the Fyne ebook. As mentioned in an earlier presentation, this was a new release at the beginning of the year, and hopefully it is assisting many people get up and running or learn more about the Fyne toolkit. Now, we didn't actually ask for permission to share names of those who subscribed to the competition, so I'm not going to read them out right now. We'll be picking them at random later today, and 10 lucky email addresses will be informed that they have received a copy of the book. There'll be instructions in an email letting you know how to claim that. So congratulations to the winners. To anybody who was really hopeful but didn't quite get a copy, then you can always head to the Pact website and have a look for it there. Thank you for everybody who signed up for tickets to be here today for the ebook competition. Thank you to anybody who selected the sponsorship ticket as well. It helped deliver the conference today. For anybody who has signed up to the live Q&A, that will be following in just a couple of minutes. Instructions will be in your email as to how to join. And that just leaves me the opportunity to say thank you very much, everybody, for being part of FyneConf this year. Thank you to our attendees, to our numerous sponsors who so generously have helped out with the project. Thank you to our speakers and to those who helped out behind the scenes. And of course, thank you so much to every one of our contributors, both the core team who worked so tirelessly and everybody who's been part of making this project what it is so far. It clearly wouldn't be here without you, and I hope that everybody who's attended appreciates your hard work. And so thank you once again for being here. Whether you've been watching live or in a recording down the road, we hope that you've found today to be enjoyable and educational, and perhaps will consider joining us next year at FyneConf 2022. Goodbye.